Daily Math Blast Week 17. 5 NBT 3A, Reading and Writing Decimals. Here we have standard form, unit form, and expanded form. They're giving us 2 of the forms, and we just have to make the third one. In the first one, we're creating the unit form. So I have 82 and 700ths. Now remember, there's many different unit forms you could create. I'm just creating one example, so yours may look different. So I'm going to use ones and hundredths. So 82 ones and 7 hundredths. So that's an example of a unit form that I can create. I could have also created 8 tens, 2 ones, 7 hundredths. Basically, it's how much of each place value would it take to create the same value. In our next line, we have standard form and unit form, and I'm going to write this in expanded form. Now I'm going to use decimal notation since we're working on decimals in this section. So I have 65 and 103 thousandths. So I'm just going to write the value of each digit. So I have 6 tens. So 6 multiplied by that 10 plus, so that was the 6, 5 in the 1, so 5 multiplied by the 1 plus, I'm going to move down here because I'm out of room. I have 1 multiplied by that 10th, and then I have 0 in my hundredths, so I don't need to put that, and I have a 3 in my thousandths place, so 3 multiplied by 1,000th. Our next line here, we need the standard form. Now I could take the unit form or the expanded form and build that. I'm going to go to the expanded form. So I have 4 multiplied by 1,000 plus 9 multiplied by 10 plus 2 multiplied by 100th. So I can put my blanks here. So I know I'm going from the hundredth to the thousand. So 4 multiplied by 1,000. So the 4 goes in the 1,000. 9 multiplied by 10. So I know my 9 goes in the tens place. And 2 multiplied by the hundredths. So 2 in the hundredths place. Now, to make it so I can read this, I have 0 tenths, 0 ones, and 0 hundredths. So 4,090 and 2 hundredths. 5 and F1, adding and subtracting fractions. Find the sum or difference, show all work using math or models. So there's many different models we can use. So I have 3 and 4/5 minus 2. I'm going to use an example of a tape diagram. So I have 3, 1, 2, 3, and then I have, so I need fifths here, so 2, 3, 4, 5, and I've got 1, 2, 4 of those. All right. Now I'm subtracting 2, so I'm going to do a comparison tape diagram. So we'll come down here. So here's 1 and then 2. Now what I'm looking for is the distance from here to, went just a little too far here. Distance from here to here. That in there. So if you notice, that's 1 and 4/5. So 1 and 4/5. So notice yours may look different. You may use a different model, but notice how my picture shows the distance of 3 and 4/5 and the distance of 2, and then my difference or my answer is the distance between those two. So now I have 4 and 3/8 plus 3 and 3/4. So I'm going to use a similar strategy here. So I have 4 and 3/8. So I've got 1, 2, 3, 4. And now I have this 3/8. So I go 1, 2, 3, 4, 5, 6, 7, 8, just to make sure. Switch my colors up, and I have 3 of those. So 1, 2, 3. And then I've got all of these too, so I'll shade these in just to make it really easy to see. So 4 and 3/8, and now I'm adding that to 3 3/4. So I go 1, 2, 3, and now this one I've got 3/4. I've got 1, 2, 3 of those. Okay. Now, the wholes are really easy to add. The trick here is the fractions. Now, to combine the fractions together, I need them to be the same size. So what I'm going to do is if I draw a line through there, notice I break that into 1, 2, 3, 4, 5, 6, 7, 8 pieces. Well, this hole is also broken up into 8 pieces. So now I can just count the little green sections. So if you notice here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 eighths. So that's 9 eighths. Well, I know 9 eighths is made up of 8 eighths and 1/8. Oh, eighth. Sorry about that. So I can actually take 1, 2, 3, 4, 5 of these. So I could take this 5 right here and move them up here and fill this in. And that would leave 1 of my eighths behind. So that means this hole. So I have 1, 2, 3, 4, 5, 6, 7, and then the 8 eighths. So that's 8. So 1, 2, 3, 4, 5, 6, 7, and then 8 and 1/8. So 8 and 1/8. 5NF2, fraction addition and subtraction word problems. You give 2/5 pan of brownies to Mrs. Cable and 1/3 to Mrs. Abruba. How much of the pan of brownies do you have left to give to Mr. Ford? So there are many different ways to look at this. I'm going to draw one model kind of showing the brownies, and I'm going to cut it up into fifths so I can figure out how many pieces that Mrs. Cable would get. And I'm going to cut the same pan of brownies, that horizontal, into thirds so I can determine how many Mrs. Abruba would get. So let's go. So I have my pan of brownies. Okay, so first I need to cut this into fifths. So I go 2, 3, 4, 5. Okay. So this would enable me to give to Mrs. Cable. She would get one of these sections here. Now, Mrs. Abruba, I'm giving 1/3. So I need to cut it in third the other direction. So this would enable me to determine 1/3. So if you look, if I go Mrs. Cable, well, I know Cable. If I look at 2/5, well, 2/5 is going to be 1 right there. So that's 2/5. So if I look right there, that's 6 pieces. So I know that's going to be 6 brownies. Right. Now I need to determine Mrs. Abruba. So if I look at the other direction here, Mrs. Abruba, it would go like that. Right. So if you go, look here, it's 1, 2, 3, 4, 5 pieces. So Abruba would be 5 brownies. So notice when I cut it, I covered those 2 brownies twice. So that means I can't give each of them the same brownie. So I'd have to come down and color in this. So 1, 2, 3, 4, 5. Give those back to Mrs. Cable there. So notice Mrs. Cable got 6 brownies. Mrs. Abruba got 5 brownies. So how many brownies are remaining? There are 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 brownies. So 4/15 pan of brownies. Remember, this is just one example of a model. So what I did is I took my pan of brownies, I used it to cut up and figure out what 2/5 would be. That would be 6 brownies. Then I used the same pan of brownies to figure out what 1/3 of the brownies would be. That would be 5 brownies. And then I just determined how many brownies would be remaining. 4 of the 15 brownies. 5MD2 line plots. The lengths of the pencils were measured to the nearest 1/4 inch. The measurements are listed in the table. Use the data in the table to create a line plot using 1/4 inches. Then answer the questions below. So the first thing I have is my line plot starts at 6 and it ends at 8. Now my information here, if you notice the word problem, it said 1/4 inch. And when I'm looking at my data, I have fourths, 2/4, halves, 3/4. So the first thing I need to determine is right here in kind of the midpoint, so eyeballing it there, would be a 7. 6, 7, 8. Then I just have to cut these up into fourths. So make that a little bigger, so there's half. And then when I'm cutting into fourths, I cut in half, and I cut each of those in half to make my pretty equal fourths. So this right here would be 6 1/4, 6 2/4, which we should know is also 6 1/2, 6 3/4, 7, 7 1/4, 7 2/4, which is also 7 1/2, and 7 3/4. Now I just simply need to record my data. Now, when I'm creating a line plot, the things I need to be very careful of is I'm going to build this using x's to represent each data point. I want my x's to be close to the same size, and when I'm stacking them on top of each other, I don't want any gaps. I want to be as consistent as possible to make it very quick and easy to read. So the first thing I have is 7 1/4 or 7 1/4. So I put my x there. 6 1/2. I'm just trying to stay as close as I can. 7 3/4. 7 1/4. So I got a little gap there, but I just want to keep that gap consistent. 6 2/4. 6 3/4. 6 1/4. 6 3/4. 6 1/2. 7 1/4. 7 and 7 1/2. And the reason I want to be very consistent is if you look across, you can see all of the values or locations with 1x are about at the same level, the 2, and then the 3. So that makes it very quick and easy to answer these questions. So what is the most frequent pencil length? So what is the most frequent pencil length? Well, we have a tie between 6 1/2 and 7 1/4. So 6 1/2 and 7 1/4. What is the shortest pencil length? Well, the shortest pencil length is the data point that's furthest to the left, and that would have been the 6 1/4. What is the longest pencil length? That would be the data point furthest to the right, and in our data right here, it's 7 3/4. Now don't be confused. We had 8 on our graph, on our number line, but we did not have a data point located there. We had 6 on our number line, but we did not have a 6 in our data. Identify the triangle by sides and angles. Provide evidence for your side angle choices. So it says sides, equilateral. That would be all 3 of identical length. Isosceles, 2 or more of identical length. And scalene, where all 3 are of different lengths. When I'm looking at this triangle, it appears as if this side and this side are of equal length. Those are the markings I use to show that. So I have 2 sides. Now if you notice this one down here at the bottom, the base is a little shorter, so it's definitely not equilateral. So this triangle would be isosceles because 2 sides are of equal length. So if all 3 were different, it would be scalene. Angles. When I'm looking at angles, what we're doing is we're looking right here, these three angles. Now, the process I use for determining the name of the triangle by angle is I look for, is it right? And remember, a right angle makes that nice L. It's like the corner of a piece of paper. So I'm looking at these three angles, this angle here, here, and here, and none of those are making that shape. And so it is definitely not right. Now, the next thing I look for is obtuse. Now, obtuse is larger than a 90-degree angle, so it's open further than that L shape. So I look at these three angles. It is definitely not obtuse. None of those angles are obtuse. So then the only remaining name is acute. Now, the reason I go in that order, I look for right and I look for obtuse, is what you'll notice when you're looking at triangles is all triangles have acute angles. But if you see a right angle, it's a right triangle. If you see an obtuse angle, it's an obtuse triangle. If you can't find either of those, then it is acute because all three angles have to be acute. So it's acute because all angles are acute. And this was Daily Math Blast Week 17. Thank you.